Welcome to the Chapter 5 videos. So if you are decent at Chapter 4, which was all about factoring, this will be insanely easy for you. So hopefully that's the case. Let's start up here at this example problem that doesn't say number 1. It's not numbered. So this guy right here is what I'm talking about. So and actually down below here, I'm going to underline this guy. Ultra important, right? Greatest common factor, always the first kind of factoring you're supposed to try. So if I look through that problem, not all the terms have x's. There's no number that goes in all of them. So that's going to default to this guy right here, which is 9 out of 10 times how we do a factoring problem. So when in doubt, factor it out. So pretty standard here. If I want to get an x squared, I go x and x. Not a whole lot of ways to get 35, so pretty likely it's 7 and 5. Can't be two plus signs, right? Because the whole problem is not plus, but I still need to get a positive 35. So how about a negative times a negative? So we're going to talk about a shortcut to solving it. So that's just factoring. That's not actually solving it. But if you do look in the directions here, step 1 says to factor, and we just did that. Step 2 would say to set each factor equal to 0. So each separate set of parentheses. Now I'm going to leave off the parentheses because if I separated them, they wouldn't be important. So if I could make x minus 7 equals 0, that would be one answer. And if I could force the x minus 5 factor to equal 0, that would be the second answer. So pretty darn simple from here. Add 7 to both sides, I get 7. Add 5 to both sides, I get positive 5. So let me show you why this holds true, why there's two separate answers. So how do we check a problem? Well, we always plug it back in, right? So if I were to take the 7 and I were to plug it in for x right here, I would have to do 7 minus 7. Well, what's 7 minus 7? It's 0. And then what's 0 times anything? Wouldn't even matter what's there. You're going to get 0. So what's another possible answer? Well, what if you checked the 5 and put the 5 right there where that x is? 5 minus 5 is 0, and again, 0 times anything is 0. So they're going to equal 0 for both cases. Shortcut, and that's what number 3 is right here. We'll just go ahead and mention that now. So if you look at the factoring and you look at the answers, what happened to the signs? They changed, and that's got to happen, right? Because inverse property for addition is breaking out properties, I know. A positive 7 and a negative 7 makes 0. Yeah. A positive 5 and a negative 5 makes 0. So it makes sense that we would have to switch the signs there. All right, let's do a couple more examples. So I like this first one, number 1, because it's going to be the one that's missed the most. And the reason is this. Set up there in the directions that you're always supposed to look for a GCF first. And in this case, it does have one. So 3 goes into both. And they both have an x. So do not assume that it's always going to be two sets of parentheses for this. All right, if I take a 3x away from the first one, that would leave me an x. 3 times what would give you 18? That would be a 6, and I factored the x out. There we go. So I'm going to show you the non-shortcut way one more time, mostly because of that 3x. Now I'm going to go ahead and do the x plus 6 first, because that's very similar to the one we just did. So would you have to switch the sign to get that 6 to the other side? And the answer is yes. So anytime you have a binomial, which is this guy, you're just basically going to switch the signs. So positive 6 and negative 6 makes 0. Kind of makes sense. But let's see what happens with this other one. So the other factor, the GCF, was literally 3x. So it said in the directions that you said each factor equal to 0. So I did. I set the x plus 6 equal to 0 separately. I set the 3x equal to 0 separately. Well, how do you solve this guy? You would have to divide by 3. And if you divide 0 by 3, you still get 0. So the shortcut for a GCF, this is going to be a GCF only, is going to be bingo, bam, it's 0, done. And the reason being, it doesn't really matter what number was right here. If that said 5x, well, what's 5 times 0? If that said negative 7x, what's negative 7 times 0? The only catch is there has to be an x there, and we'll talk about that later. Okay, so we're going to try shortcuts from here on out. Number 2 does not have a greatest common factor, and if it doesn't have a greatest common factor, it's got to be this. So to get n squared, I want to go n and n. What times what would be 28? A 7 and a 4. So remember, you know how to check these outside inside. Please try to ignore the phone ringing in the background. So the negative 7 and a positive 4 would not only get me negative 28, but it will check out, give me the negative 3. So again, you could set these both equal to 0. You could separate them and put an equal 0 on each one. But I'm going to go shortcut. What number minus 7 is 0? Positive 7. What number plus 4 is 0? Negative 4. So all you have to do is switch the signs. No GCF for number 3. Got to be this. J and J to get my J squared. A couple different ways to get 81. If I use 9 and 9, that's going to add up to that 18 in the middle. Nothing but plus signs. So nothing but plus signs in my factoring. So do you recall that the complete square method and simplest form for factoring would be to say, hey, if I get a J plus 9 and another J plus 9, I'm supposed to write it J plus 9 squared. But here's the one time you get to forget that detail. And the reason is you're just trying to tell me what J equals to make it equal 0 for an answer. So if I switch the sign and I get negative 9 plus 9 is 0. I wouldn't have to take the time to write a J plus 9 squared to arrive at that. Now, what would this second set of parentheses be? Wouldn't that be the same number? Now, if you want to write down negative 9 a second time to remind yourself that you got two answers, that's fine. But there's no reason to. So coincidentally, that guy ends up with the same answer twice. Okay, number 4. A little more difficult, only in the sense that there's not 0 on the end. So if you think about it, negative 5 and positive 5 is 0. Positive 7 and negative 7 is 0. So the only way I can solve these is if I have it set equal to 0. So that's the first thing I want to do. I'm going to move that 8y over by adding him. I'm going to put the order in the normal order you would see it. So the squared term goes first, the y in the middle, the constant, and the negative 9 on the end. And then we can factor it. So one extra little step there, not that big a deal. Well, y squared's got to be y and y. So everybody wants to go 3 and 3 for 9, but that's not going to add up to an 8 in the middle. So how about 9 times 1? That would be 9. And if I went with a positive 9 and a negative 1, if I add those together, you're going to get positive 8, and you will. So again, remember, outside, inside for checking purposes. I'm not going to write it out here, but it's never a bad idea. Shortcut. Switch the sign. Why am I switching the sign? Because negative 9 and positive 9 make 0. Shortcut. Switch the sign on the second set of parentheses. Why? Because positive 1 and negative 1 make 0. All right, number 5, a little tougher. You should still check for GCFs. Is there a number that goes into all of those? And the answer is no. Do they all have X's? No. So it's got to be this thing. So this was the kind of factoring that was tougher because you have a leading coefficient or you have a number out there in front that 5. But that doesn't make it any harder to get 5x squared, right? That's going to be 5x times 1x. So the dilemma is going to be, how do you come up with the 6? So try to remember this. That number in the middle is pretty big. If he's pretty big, I want to use big combinations. I don't want to use 2 times 3 for 6. I'm more likely to have 6 and 1 work. So the signs, I have to get a negative 6. So one's got to be negative, one's got to be a positive. So I'm going to check this one real quick. Multiply the outside 2 guys, I get negative 30. Multiply the inside 2 guys, I get 1. And does that add up to negative 29? And the answer is yes. So switch the sign, and I get 6. Now, I'm going to do the long way here for number 5. So remember, the long way was to set each one equal to 0 and solve it. And the reason I'm doing that is because if you notice, there's 2 numbers in that set of parentheses this time. So the answer is not negative 1. Here's why. How do I get the 1 to the other side? I subtract it. And how do I get rid of the 5? I would divide. So the answer to that guy is negative 1/5. So you can always do that method no matter what. But there is a shortcut. Take a look. There was a 5 and a 1 in the parentheses. If you make it into a fraction, that's a shortcut. So if you watch the part 2 video, we'll demonstrate that again. And you did still have to switch the signs. Hey guys, thanks for watching part 1.